All right, this video is going to go over Module 3, Homework 2, Rational Exponents. So just before we even get started, that word rational, another word for rational is fraction. So it's the same thing as saying fraction exponents. So radical is like the square root. That's about last section. Rational is fraction. So rational exponents are fractional exponents, something like x to the power of 7 divided by 10 or x to the power of a divided by b. Then we also have radical notation, which is using radicals like square root, cube root, all that good stuff. So I can write a rational exponent in a radical notation. There's two different ways of writing it. A fraction exponent is the same thing as saying a radical, just two different ways of writing it. So x to the power of 7 over 10 is the same thing as saying the 10th root of x to the 7th power. Notice that x is our base, 7's up top, it's going to stay up top, and that 10 is the bottom of our fraction, so it's going to be our roots, like the trees are, roots are at bottom of a tree, our root's going to be at the bottom of our fraction. So our little template is x to the a over b is the bth root of x to the a power. So the radical expression, the eighth root of x to the 7th can be rewritten in rational exponent form, x to the a over b, where a is blank and b is blank. All right, so we have x, the eighth root of x to the 7th. So x is our base. That 7's up top, it's going to stay up top. 8 is our root, so it's going to go to the bottom of our fraction. So the eighth root of x to the 7th power is the same thing as saying x to the power of 7 over 8, where up top a is going to be 7, and on the bottom b is going to be 8. So a is 7, b is 8. So evaluate the power without using a calculator. If we had 64 to the 1/3 power, putting this in rational exponent form into radical notation. So our base is 64, so it's going to stay our base. That 1's up top is going to stay up top, and that 3's out of our fraction, so it's going to be in our root. Notice again, our root is inside that little check mark symbol, so it's a little 3 inside. So we really have the cubed root of 64. Let's break down 64. I don't know, 8 times 8. We're looking for 3 of a kind this. Let's break down 8. 8 is 2 times 4. 2 is going to get circled. 4 is 2 times 2. Same thing over here. 8 is 2 times 4. 2 is going to get circled. 4 is 2 times 2. So underneath the cubed root, we really have 2 times 2 times 2 times 2 times 2 times 2. Oops. It's the cubed root, meaning we're looking for 3 of a kind. So these 3 2's are going to come outside the radical, and these 3 2's are going to come outside the radical. Nothing's up underneath the radical, so the radical goes away. We're left with 2 times 2, which is 4. Same thing over here. I have 64 to negative 64 to the 1/3 power. So notice negative 64 is our root this time. So that negative 64 is going underneath our radical. 1's up top, it's going to stay up top. The 3's on the bottom, so it's going to go inside of our root. So you really have the cubed root of negative 64. So remember, it's an odd root of a negative, so we can break down that negative. Oops. Odd, so break down the negative under the radical. I was going to say it's an odd root. So I have negative 64, which is negative 1 times 64. We're looking for 3 of a kind, so I can break down that negative 1 into negative 1 times negative 1 times negative 1. That gives me that 3 of a kind that we're looking for. And 64, just like we did over here, we said 8 times 8. 8 is 2 times 4. 2's going to get circled. 4 is 2 times 2. Likewise over here, 2 times 4, which is 2 times 2. So underneath the cubed root, we have -1 times -1 times -1 times 2 times 2 times 2 times 2 times 2 times 2. It's the cubed root, so we're looking for 3 of a kind. So these 3 -1s are going to come outside the radical. These 3 2's are going to come outside the radical. These 3 2's are going to come outside the radical. Nothing's left underneath the radical, so the radical goes away. So we're left with -1 times 2 times 2, which would give us -4. So we will use exponent properties a lot. So going back to Module 2, Homework 5, so let's recap real quick. Just little exponent properties that we used. So the property of saying a to the m times a to the n, we added those exponents, a to the m plus n. Here's an example. 3 to the second power times 3 to the x power equals 3 to the power of 2 plus x. A to the m divided by a to the n, we subtracted those exponents, so we got a to the m minus n. For example, 3 to the 2 power divided by 3 to the x power will give us 3 to the power of 2 minus x. A to the m to the n, we multiplied these exponents, so that'll give us a to the m times n. So 3 to the second to the x will give us 3 to the 2x. Then we had ab to the m power. We can distribute those exponents if there's no adding and subtracting. So a to the m times b to the m. Likewise, a divided by b to the m power will give us a to the m divided by b to the m. So our examples are 3x squared will give us 3 squared times x squared. There's no adding or subtracting, so I was able to do this. 3 divided by x squared will give us 3 squared divided by x squared. Lastly, we can now add this new rule going from a radical to rational exponent form. So the the rth root of x to the p power will equal x to the power of p divided by r. So remember, the numerator is the power. So the numerator here is our power. If it's on top, it stays on top. And the denominator is our index. If it's on the bottom, it kind of stays on the bottom. So for example, the 5th root of 2 cubed is the same thing as saying 2 to the power of 3 divided by 5. So these are all things, and then now we have this last one, which is our new one. But these were all from Module 2, Homework 5. All right, next page. So rewrite the expression. I'll try to focus and see if it looks any better. There we go. Rewrite the expression 10x to the power of 3 divided by 7 in radical form. Going back to test 1, remember that the exponent only applies to whatever's directly underneath it. So that 3 over 7 power only applies to the x, not to the 10. So the exponent only applies to what is directly underneath it. So that 10's out front is going to stay out front. And that x is to the power of 3 over 7. It is a fraction exponent, so we know it's going to be a radical. Our base is x. That 3 is up top. It's going to stay up top. That 7 is on the bottom, so it's going to be our index. So we have 10 times the 7th root of x cubed. So notice it's a little 7 inside the check mark symbol, and it's a little 3 up top as an exponent. Next, simplifying the expression z to the 1/5 to the 1/3. Assume that z is greater than 0, meaning it's positive. So part A says write the simplified expression using a positive exponent. Be sure that your variable matches the question. So meaning that this is a lowercase z, so my answer needs to be a lowercase z. Power to a power, that means we are going to multiply our exponents. So that'll give us z 1/3 times, 1/5 times 1/3. 1/5 times 1/3 times 1/5 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 times 1 We're multiplying fractions, so top times top, bottom times bottom. So 1 times 1 will give us 1, all over 5 times 3, which is 15. So I have z to the power of 1 divided by 15. Part B says a simplified expression can be written in the form of the nth root of z to the m, or the nth root of z and then all to the n power. Either way, as long as that m is an exponent, we're fine. So let's write it in radical form, basically is what it's saying. So we have a fraction exponent, so we know it's going to be a radical. Z is our base. That 1's up top, it's going to stay up top, and that 15's on the bottom, so we know it's going to be our root. So here, our n, I'm going to use a little different color, is going to be 15, and our m up top is going to be 1. So n is our root, which is 15. M is our exponent, which is 1. Normally we wouldn't write that 1. We would just say the 15th root of z. All right, let's do the next one. Evaluate the expression 27 to the power of negative 4 divided by 3, negative 4/3. This is a negative exponent, so we can say, okay, this will flip across the fraction bar. There's no fraction really, so it's going to go automatically to the bottom. So I know that 27, because it's negative exponent, it's going to flip down to the bottom and become positive. So 27 to the positive 4/3 power now. Right where you can see it better. There's nothing up top, so I need to put a 1 to show that, okay, this is a fraction. There's nothing up top, so I kind of need like a placeholder. So your calculator, you can use your calculator for this one. So let's say 27, oops, it helps if I turn it on. 27 to the power, so I'm going to use this caret button right here, which is my exponents, of 4 divided by 3. Whenever you do 4 divided by 3, it's a fraction. So you just show in your calculator that it's its own fraction, so you need to put it in parentheses. So in parentheses, 4 divided by 3 equals, and that will give us 81. So I have 1 over 81. So little note. So let's put this in our calculator. As 27 to the power, in parentheses, 4 divided by 3. And then press enter. If you were to put this long-handedly, I guess you would say, we would have 27 to the 4/3 power. So in radical form, my base is 27, that 4 is up top, it's going to stay up top, that 3 is on the bottom. We'd write 27 to the 4th power, which is that crazy big number. So we have cubed root of that crazy number, so 531,441. We would break down this number and then see 3 of kinds, all that good stuff. But thankfully our calculator did that for us. Let's do the next one. Evaluate negative 27 to the 2/3 power. So let's see. Let me just make sure that I'm telling you the right thing. Give me 2 seconds. Just so that way I can see that exactly how they want it in the homework. So All right. Gotta make sure. Here we go. Okay, yep, found it. All right. So we know negative 27 to the 2/3 power. So negative 27 is going to be our base. It's fraction exponent, so we know it's going to be a radical. 2's up top, it's going to stay up top. That 3's on the bottom, so it's going to go down as our root. So we really have the cubed root of negative 27 squared. So negative 27 squared will give us negative 27 times negative 27, which is 729. So we have the cubed root of 729. So let's break down that 729. 2 doesn't go into it. Let's see, 729 divided by 3. 3 times 243. Let's see, 243 would give us 3 times 81. 3 is going to get circled. 81 is 3 times 27. 27 is 3 times 9. And then 9 is 3 times 3. Ooh, a lot of 3's. So we really have the cubed root of 3 times 3 times 3 times 3 times 3 times 3. 3 times 3 times 3 times 3 times 3 times 3. It's the cubed root. Ooh, we got a lot of 3's going on here. So we're taking out 3 of a kind. So these 3 3's are going to come outside the radical as just 3. These 3 3's are going to come outside the radical as just 3. There's nothing left underneath the radical, so the radical goes away. We're left with 3 times 3, which is 9. Next one, try to evaluate negative 16 to the negative 1/2 power without using a calculator. So remember, this exponent applies only to whatever's directly underneath it. So that negative 1/2 power only applies to the 16. So we have negative 1, if you want to say, times 16 to the negative 1/2 power. That negative exponent means it's going to be flipped down to the bottom. So that negative 1's out front is just going to stay out front. So I now have 1 over 16 to the 1/2 power. Again, that negative exponent flips it down to the bottom. So I have negative 1. Just don't forget to bring down this negative 1. Times 1 over, it's a fraction exponent, so we know it's going to be a radical. 16 is our base. Our exponent up top is 1, and our root is 2. So I really have negative 1 times 16. I'm sorry, negative 1 times 1 over the square root of 16. Bringing down that negative 1 times 1 over the square root of 16 is 4. 4 times 4 is 16. We have negative 1 times 1/4, which is negative 1/4 as our final answer. So negative 1/4. So see, I got slowly, little baby steps along the way to get to our final answer. All right, let's go to the next page. You can pause it if you need to, fast forward, rewind, all that good stuff. So we talked about earlier that we're going to use our exponent properties. So use the properties of exponents to simplify the following as much as possible. Assume that all bases are positive. So x to the 4/5 power divided by x to the 3/4 power. They're both base x's, so I combine them together using the same base x. They are being divided, so that means we are going to subtract our exponents. So we have x to the 4 divided by 5 minus 3/4. We have to get a common denominator because we are subtracting fractions. So if we have 4/5 minus 3/4, getting a common denominator should be 20. So our LCD would be 20. To make this first denominator to 20, I can multiply by 4. So to keep the equation balanced, multiply the top and the bottom by 4. Second denominator, I can make it into 20 by multiplying by 5. So multiply the top and the bottom by 5. That'll leave us with x to the 4 times 4, which is 16. divided by 4 times 5, which is 20, minus 3 times 5, which is 15, divided by 4 times 5, which is 20. So now I have x to the power of 16 twentieths minus 15 twentieths. So now combining like terms, I get x to the power of 1 over 20. Everything's positive. We're done. Final answer is x to the 1 over 20th power. Next one, use the properties of exponents to simplify the following as much as possible. Assume that all bases are positive. X to the 1/3 power times x to the 1/4 power. They are being multiplied. They're both base x, so I can write it as the same base x. And we can add our exponents because we're multiplying. So I have x to the 1/3 plus 1/4. I need to get a common denominator. So if I have 4 and 3 as my denominator, my common denominator could be 12. I can make this first fraction with a denominator of 12 by multiplying the top and the bottom by 4. I can make the second fraction have a denominator of 12, multiplying the top and the bottom by 3. That'll leave us with x to the 4 over 12 power plus 3 over 12. So now they are like terms. Let's combine them together. So x to the 4/12 plus 3/12 will give us 7/12. So that's our final answer, x to the power of 7 over 12. Our exponents are positive. Everything simplified. We're done. So simplify using the rules of exponents. 2 to the power of 7/4 times 2 to the power of 5/8. They're both base 2, so I can combine it into the same base 2. It's being multiplied together, so that means we can add our exponents. So adding our exponents, I have 2 to the power of 7/4 plus 5 over 8. We need to get a common denominator. If our denominators are 4 and 8, we can get a common denominator of 8. So this first fraction, to turn it into a denominator of 8, I can multiply the top and the bottom by 2. The second fraction already has a denominator of 8, so it's good to go. So that'll tell us it's 2. 2 times 7, which will give us 14, all over 2 times 4, which is 8. Plus 5/8. So 2 to the power of 14/8 plus 5/8. 14/8 plus 5/8 would give us 19/8. So 2 to the power of 19 over 8. Everything simplified, positive exponents, we're done. 2 to the power of 19 over 8. Next page. Simplify the following expression. Assume that all variables are positive. Write your answer as a reduced fraction. So if we had the square root of 14 times the 4th root of x to the 5th power, square root of x to the 14th times the 4th root of x to the 5th power. Now they're both base x's, but they're not the same root. I have the square root and I have the 4th root. So I can't combine them yet. But if I turn these into fraction exponents, my base is x. 14's up top is going to stay up top. My root is 2, so 14 divided by 2 times x is my base. 5's up top, it's going to stay up top. 4 is my root, so that's going to go to the bottom. So now I have like terms. So I have x to the 14 over 2 times x to the 5 over 4. So now they're like terms. Now they're both x's. They're being multiplied, so we can combine them together by adding our exponents. Now I have 14 over 2. 14 divided by 2 is 7. So if you want to write 7, that's fine. I'm going to leave it. I'm going to simplify it at the very end because I know I'm about to get a common denominator anyways. So if we have 2 and 4, my LCD should be 4. Let's go ahead and let's add these exponents together. So x to the power of 14 divided by 2 plus 5 divided by 4. I can make this first denominator into 4 by multiplying the top and the bottom by 2. The second denominator is already 4, so it's good to go. So I have x to the 2 times 14, which is 28. So 28 over 4 plus 5 over 4. So now my base is x, 28 fourths plus 5 fourths. Now they're like terms. Combining it together, 28 plus 5 will give us 33 fourths, which is our final answer. But notice up here how it says x to the a power. So this is our a. So our a would equal 33 over 4. Because x to the a power, I just want you to put it in as an exponent. All right, let's do the next one. Simplify the following expression using the laws of exponents, the properties we talked about in Module 2, Homework 5. All variables are positive and express your answer using positive exponents. So x to the 33 power times y to the negative 6 all over 27 to the 2/3 power. There's no adding or subtracting here, so we can take this exponent and we can distribute it to every single term inside the parentheses. So x to the 33 to the 2/3 power times y to the negative 6 to the 2/3 power divided by 27 to the 2/3 power. Now, if you want to write it as 33 over 1, go for it, and negative 6 over 1, go for it, because we have a power to a power. So whenever we have a power to a power, we are going to multiply these exponents. So exponent times an exponent, fraction times a fraction, top times top, bottom times bottom. So I have x to the power of 33 times 2, which is 66, divided by 1 times 3, which is 3, times y to the negative 6 times 2, which is negative 12, all over 1 times 3, which is 3, all over 27 to the 2/3 power. Now, side note, let's try to see if we can simplify this easily by plugging it to our calculator like we did earlier. So in parentheses 27 to the power of, in parentheses 2 divided by 3. And that will give us 9. Oh, that's nice. That'll make that a lot easier for us. So a little side note in our calculator. So we did 27 in parentheses to the power of 2 divided by 3. That gave us 9. All right, let's simplify. So we have x to the 66 divided by 3, which should give us 22. So x to the 22nd power. Y to the negative 12 divided by 3 will give us negative 4 all over 9. Almost done. Now our last thing is we have to have positive exponents. So to make this y to the negative 4th power positive, let's flip it across the fraction bar. It's up top, so let's flip it down to the bottom. So our final answer will be that x to 22 is up top. It's going to stay up top. All over 9, y, and now that becomes positive 4. Everything's positive, everything's simplified, done. X to the 22nd power divided by 9, y to the 4th. All right, last two. So simplify the following expression. Assume that x is greater than 0, x is positive, and write your answer without radicals. All right, so the reason why it says it's assume that x is greater than 0, x is positive, is because we have radicals. Whenever you have radicals, then it comes into i's and all that stuff. So 81x to the 1/2 power. Let's go ahead and let's distribute that 1/2 power to both terms. Or let's say, there's so many ways you can do it. Let's go ahead and say, okay, it's 81x to the 1/2 power. So that 1/2 power is applied to whatever's underneath it. So it's a fraction exponent, so we can have a radical. Our base is 81x. That 1's up top, it's going to stay up top. That 2 is outside. So we really have the square root of 81x, which we know 81 is 9 times 9. So I have the square root of 9 times 9 times x. I don't have to break down the 9's anymore because it's a perfect square, meaning these two 9's can come out. So we're left with 9 square roots of x. But it said write without using radicals. So I know that 1's up top, it's going to stay up top. That 2 is down. So I can rewrite this back into fraction form as 9 times x to the 1/2 power. And then bringing this down here, times negative 6 times x to the 4/7 power. Remember that 4/7 power is only applied to whatever is directly underneath it. It's only applied to the x. So now let's combine some like terms. We have 9 times negative 6, which 9 times negative 6 will give us negative 54. So negative 54. have x to the 1/2 power times x to the 4/7 power. We are multiplying, so that means we can add our exponents. So x to the 1/2 plus 4/7. So add our exponents. We are adding fractions, so that means we have to get a common denominator. So if we have 2 and 7 as our denominator, I can make them both into 14. So our LCD should be 14. So multiply this first fraction top and the bottom by 7 and the second fraction on top and the bottom by 2 to make them both into 14 as our denominator. That'll leave us with negative 54 just hanging out front. X to the power of 7/14 plus 8/14, which would leave us with our final answer of negative 54x. 7/14 plus 8/14 will give us 15/14. So that's it. So negative 54 times x to the power of 15/14. Try to put it all on one page. There you go. All right, last example. It says simplify x to the negative 2/3 power, y to the 1/2 power, all over x to the negative 2/3 power, y to the negative 1/2 power, x squared, all to the negative 1/5 power. So let's go ahead and say, okay, there's no adding and subtracting. Let's distribute this negative 1/5 power to every single term inside the parentheses. So we have x to the negative 2/3 to the negative 1/5 times y to the 1/2 to the negative 1/5 all over x to the negative 2/3 to the negative 1/5 times y to the negative 1/2 to the negative 1/5 times x squared to the negative 1/5. So everything got that negative 1/5 power. So now exponent power raised to a power, so we are going to multiply these exponents. We're going to multiply these exponents. So that'll leave us with x negative 2/3 times negative 1/5. Negative times a negative is a positive. We're multiplying fractions, so top times top, bottom times bottom. 2 times 1 is 2. All over 3 times 5 is 15. Times y, negative positive 1/2 times a negative 1/5, so it'll be negative. 1 times 1 is 1. All over 2 times 5 is 10. All over x, negative 2/3 times negative 1/5, just like we did up here. Negative times a negative is positive. And we get 2/15 times y, negative 1/2 times negative 1/5. Negative times a negative is a positive. Up top, 1 times 1 is 1. On the bottom, 2 times 5 is 10. Times x to the 2 times negative 1/5. If you want to write it as 2/1, go for it. We know it's going to be negative. Up top, 2 times 1 is 2. Divided by 1 times 5, which is 5. So let's go ahead and make some of these negative exponents positive by flipping them across the fraction bar. So this negative x y to the negative 1/10 is going to flip down to the bottom to become a positive exponent. This x to the negative 2/5 is going to go up to the top to become positive. So we're left with x to the 2/5 times x to the 2/5 divided by x, oops, this was 15, right? Yep. X to the 2/15 times x right here, times x to the 2/5 came up top. On the bottom, we have x to the 2/15 times this y to the 10th came down, times y to the 1/10th is already there, stays on the bottom. That came up, so we're good. So here I have x to the 2/15 divided by x to the 2/15. Same thing on the top and same thing on the bottom, so they cancel out. Or if you think about subtracting our exponents, 2/15 minus 2/15 will give you 0, so those cancel out. And then lastly, we can combine our y's. I have y to the 1/10 times y to the 1/10, so we can multiplying, so we're going to add our exponents. So we're left over with x to the 2 over 5 divided by y to the 1/10 plus 1/10, which would give us x to the 2 over 5 divided by y to the 2/10, which 2/10 can be simplified down. I can divide the top and the bottom by 2 to simplify this fraction. And it'll finally give us our final answer of x to the 2 over 5 divided by y to the 1/5. Everything is simplified. Our exponents are positive. We are done. So that is all of Module 3 Homework 2. You can now complete your Module 3 Homework 2 assignment. If you have any questions, please let me or one of the tutors know. If not, thank you very much for watching.